In this video, we're going to talk about n-term tests for divergence. You know that the infinite series converges only if infinite series has a finite sum. If it does not have a finite sum, then we say the infinite series diverges. So how do we know that infinite series diverges? Well, according to the n-term test for divergence, infinite series diverges if limit as n goes to infinity of a of n equals 0. Again, infinite series diverges if this happens. So what happens when limit as n approaches infinity of a of n equals 0? When this happens, the n-term test becomes inconclusive. We don't know whether the infinite series will diverge or converge. So be careful. When this happens, we cannot tell whether the infinite series converges or diverges. We only know that infinite series diverges only if this happens. Let's take a look at this infinite series. When we write this infinite series using sigma notation, this is what we get. So what happens? Can we find the finite sum? If so, then we call it that infinite series converges. If not, then the infinite series diverges. So let's first find a of n. What is our a of n? A of n is going to be quantity negative 1 to the n plus 1. So what happens as limit as n approaches infinity of a of n, which is quantity negative 1 to the n plus 1. As n goes to infinity, notice this alternates between negative 1 and 1. So we know that it does not go to 0. So therefore, by the n-term test, we could conclude that this series diverges. And notice what happens when you add this up. You get 1, right? When you add this up, you get 0. And when you add 1, you get 1 again. And you get 0, 1, 0. It alternates. We do not approach any value. That's what this n-term test is saying. So this series diverges. We cannot find the finite sum. What about this infinite series? What's happening is that you keep adding 21 infinite number of times. So it's kind of obvious that this infinite series diverges because we cannot find the finite sum. And another way of looking at it is this. What is a of n? A of n is 21. So what happens as limit as n goes to infinity of 21? Well, we know that this is not equal to 0 because limit of as n approaches infinity of 21 is 21. So therefore, by the n-term test, we can conclude that this infinite series diverges. What about this infinite series? Our a of n is 3 to the n. So what happens as limit as n goes to infinity of 3 to the n? As n goes to infinity, that goes to infinity. So we know that that is not equal to 0. So what can we conclude? We can conclude that this infinite series diverges by the n-term test. Now what about this infinite series? Our a of n is 1 over n. And what happens as limit as n goes to infinity of 1 over n? As n goes to infinity, this approaches 0. So what can we conclude now? This is equal to 0. Well, the n-term test is inconclusive. By the n-term test, we do not know whether this series will converge or diverge. We have to use different tests. And again, be careful. A lot of times students think that when you get equals 0, they conclude that this series converges. However, the n-term test only guarantees when this is not equal to 0 that the series diverges. When we get this result, this test is inconclusive. We have to use different tests.